All right, so last time we started looking at string processing, and we did an exercise where you can directly manipulate the contents of a string character by character. We did that by creating a function that converted everything to uppercase. We also used the C-type library to do that because we have these functions is alpha, is space, is upper, is lower, to upper, to lower to convert them back and forth, and is digit, right? If it's true if it's the digit 0 through 9. This is only a small sample here, right? If you actually read the documentation on the C-type library, you'll find that there are maybe 24 different functions there that you can use for whatever you're trying to do, right? String processing can be done character by character, or you can use the string library functions to do things, to do bigger things that operate on the entire string at once. The first solution that we'll look at here is string formatting, right? So printf, you're all familiar with that. That can be used to format a string output that is going to be printed to the console, to the standard output. There is another version of this called sprintf, or sprintf. It will format a result to a string, right? So instead of outputting this directly to the standard output, you can format it so that it's stored in a string, and then you can further manipulate that string if you want to. This is really useful if you need to do some intermediate operations. You need to format it in a certain way, and then you want to print it out, or you want to, say, not print it out to the standard output, but you want to print it out to a file, which is what we'll be looking at next week. Here's a quick example. All right, so we've already got that. We'll use that later here in a second. But usually, if I've got an integer, if I've got a double, 3.14, we'll leave it like that. Say that I've got a character, right? C is equal to C for computing, or sorry, a single character there, C for computing, right? Now, if I were to use the regular old printf, I could print each one of these things out using these typical placeholders. %d for an integer, right? Y is equal to %f for a floating point number, and %c for a character. In fact, let's go ahead and also include that s up there, that string, right? That str is equal to, right? There's my formatting, and then I would have x, y, c, and then str. And let's look at the results of this really quick to see what it looks like. Oops, GCC demo, right? All right. And there is the typical formatting, right? Let's go ahead and add an inline character at the end so that it looks nice and pretty, right? And recompile this and rerun it. There we go. So 42, 3.14 with 6 decimals of accuracy because that is the default. You can also use, the regular placeholders here if you want to. Let's go ahead and print out a minimum of 20 columns, 2 decimals of accuracy, and you see here that it's widely padded with a bunch of spaces. Well, what about sprintf? That's not going to print out to the output. That's going to print out to a string. So first of all, I need the string to print to. And I'm going to create a new string here, and I'm going to use a special name for it, buffer. You're probably all familiar with the concept of buffers or buffering, right? When you're watching a video and then it pauses and it says buffering because it's downloading more data. Well, where is that data stored? It's stored in a memory location, a buffer. And then as more data is downloaded, it's added to the end. As you watch the video, then it progresses in the bar there. We need temporary storage here. And so my strategy is simply going to be, let's create a buffer that's big enough to hold whatever this is. Because if I don't have a buffer here, I'm going to have to go through and count up each and every single character. 1, 2, 3, 4. That digit was that 42. That's going to require 2, so that's 6, 7, 8, 9, 10, 11, 12. Oh, and then a minimum of 20 with 2, so that's going to be like 20, 21. I've already lost count, right? So I'm going to make this big enough to certainly hold whatever I want, right? This is way less than 100 characters here, or 1,000 characters. So now instead of printing it to the standard output, I'm going to print it to the buffer, right? And that's where, remember, it follows the same kind of strategy as everything else. The thing that you want to put is on the left-hand side, and then the thing that you want to put into the thing on the left-hand side is on the right-hand side, just like strcpy, strcat, etc. Let's go ahead and print it out to make sure that it worked, right? Because as it is right now, it's not going to actually print out anything. It printed to the string. It was storing that string in memory somewhere. Let me prove to you that it actually worked, right? The buffer is equal to %s. There we go. End the line. And let's print out the buffer. Colors are all off there. Now they corrected themselves. Right, slow today, but there you go. Right. So there's what was stored in the buffer. What was originally output to the standard output there. Now really quick here, why did I have a space at the bottom here? Look at all the end-line characters that I printed. There's an end-line character where? In the buffer. There's an end-line character here when I print it. So consequently, there's an end-line character here, and then another end-line character giving me this blank line. When you're processing strings, you do have to watch out for spaces, for end-line characters, and things like that. Okay. In fact, in your hack this week, you will be writing a function to remove certain characters, or remove white space characters, or whatever. Right? You could do something like that. In fact, we'll do an exercise similar to that here, maybe momentarily. Right? Some other things that you can do. Substrings, or substringing, I guess. Substringing, that's not a word, but some substrings. A substring of a string is a part of it, right? It may begin inside this string. Right? So for example, say Husker is a substring of that string that I was working with before. Go Husker football, right? That's just one of many possible substrings of that. There we go. And let me surround that with a, there we go. That's even better. Husker is a substring. It doesn't begin at the beginning, right? It begins here at the 4th character, which would be at index 3, right? And then it goes all the way over here to the R character. That's a substring, right? So what I want to do, here's my goal, right? Goal. Write a function that returns a substring of a given string, right? I want to write a function that if I gave it this thing, it would give this back to me here. Right? So let's design that function from the bottom up over here, okay? First of all, what should you call this function? Just label it what it is. What does it do? Gives you a substring, right? I don't get substring. There we go. All right. It's going to take a string, which is a char star s, or str. Now, what am I going to put in front here? Am I going to be? Do you want me to make changes to your original string? Probably not. You want to give me a new string. This new Husker is here. So put const in front of it so that I'm making that promise I am not going to change your string. Okay? What's my return type here? I need to give you a new string, so that'll be? Char. Just one? That's one character. A string would be char star. Right? Space there or not, whatever you want. Right? All right, let's go ahead and, well, how is it going to get that substring? Right? It could be Husker. Well, what if you wanted the substring football? Or what if you did want the substring go Husker, right? Or what if you just wanted the substring here, this last character, which is just an exclamation point for some reason, right? So we need to define this behavior. Right? There are a couple of options here, right? We could say, given the start index, gives you the substring starting at that index all the way to the end, right? There's my first choice, right? What's another way that we could do this? You give me a start index, that's where you want the substring to start. I don't want you to go all the way to the end, though. I want you to stop right here, right? So you could be given start index and end index, right? Right? So that's another option. What else could you do? With this particular example, I want you to start at index 3 because I want you to get that Huskers, and I want to go from 3, 4, 5, 6, 7, all right, 8. In other words, I want a string of length 6. Right? So given a start index and a length, right, return that substring. Right? You start at this start index, and then I want of length 5. Okay, I'll give you these 5 characters right here in a brand new string. Right? We could do all of these, right? Each individual one. Which one is the most useful, do you think? What about the first one? Is that the most useful? You started at a location, but you don't get a choice as to the ending location. That doesn't sound more general. In fact, if I did the second one here, couldn't I get the same behavior as the first one? All I'd have to do is start at this index 3, go all the way to the end. Okay, well, I can do the math there. The length of the string, I want you to go all the way to the end of it. Right? So I could write this function in terms of this version. Right? So what about 2 versus 3? I'd say they're about the same. I mean, one is no better than the other. So you guys choose. Do you want to do this first one, or do you want to do the second one here? Second, this one, or 2 or 3? 3? Okay. Let's do 3. There we go. To do write those other versions. In fact, once we write this version, those other 2 versions are going to be single lines of code, right? Because you're going to call this function that we're about to write. Right? All right, given a start index and length, returns a new string starting at the given index and of the given length. That means that I'm going to have to pass those in as parameters. So int start index and int length. Okay? All right, let's actually write this thing now. Oops. There we go. What's the very first thing I should do in any function that I write? Error handling. What could go wrong with each one of these? Let's work left to right. What could go wrong with S? Null, right? If that's null, or what could go wrong with start index here? Start index is negative. Or what else could go wrong with it? Is greater than length. This length, I don't know. What if the input is hello world, right? And that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if it were 11 right here? Right? Do you want to start at the end? That seems wrong. So the length, yes, but whose length? S's length, right? If that's greater than or equal to, because think about this, right? If it's HELLO, 0, 1, 2, 3, 4, the length is 5, but you can start at 4 and go to the end. But what happens if you want to start it over here after the string ends? That doesn't make any sense, right? So again, think about these in terms of, well, I want you to start at index 5 for just hello, right? But the length of that is 5, and that's wrong, right? Because that would be starting like right here, right after the string starts. So let's go ahead and restore those. And this is a nice feature that goes all the way back to week 4, or actually week 3. Do you remember we talked about something called short circuiting? All right. This is potentially dangerous right here. If S is not a valid string, what happens when you pass in null for strlen, right? You'll probably get a dereferencing error, right? A segmentation fault. But is that going to happen here? Because we check for null first, and if this is true, what happens to the rest of this since it's an OR, a disjunction? Doesn't get executed. This is a common pattern, and this is why short circuiting exists, or still exists to this day. All right, I'll just put in a to-do here. To-do, think about others. Yeah, go ahead.
Yeah, so if you would have changed the order, done the error handling from the start index,
yep.
what would have been?
If you change the ordering on this, it is wrong, right? Because now you're assuming that you have a valid string to be able to call strlen. This will seg fault if it's null, never actually getting over to this part. Right? So undo, undo, undo. There we go. There are other error conditions here. For example, what happens if the length is negative? What happens if you start at index whatever, and you said that you wanted a length 1,000, but there were only 4 more characters, right? You're falling off the end of the string. So to do, think about some others here. But what should we return here? Should we return an error code of 1 or 2 or certainly not 0, right? Right? What should we return here to indicate something went wrong because the return type is a pointer? Null. Okay. All right. All right. Steps. Let's outline this. Let's whiteboard this. 1. You need a new string. So create a new string of length ... How big should the new string be? Aren't I telling you that? Right? Length of length. Let me put a colon in that to disambiguate it. Right? All right, so if you want to copy over Husker, Husker, are 6 characters enough? 7. Why? For the null terminating character. So length plus 1. 2. Copy over the characters starting at start index up to ... Start index plus length. Let's think about that. Start index, whatever it is here. I want to copy HELLO. So whatever this is, plus 1, 2, 3, 4. Oh, okay. Minus 1. All right. Think about this. If you wanted to start at the 0th index, then that becomes 0, that becomes 0, and you want to copy over hello, which is of length 5. So where index do you want to stop at? 0, 1, 2, 3, 4. You always need to make sure that you're taking care of this because we count starting at 0 in computer science. All right. If it ever helps, use actual numbers. This is why you whiteboard stuff. Use an actual example, think about what the indices should be, and then extrapolate from that the general form of these. Right? Then go back, think of another example, goodbye, right? And see if your formulas, like the one I just put up there, do they still work under that different example. Right? And then finally return the new string. Okay. Create a new string of length plus 1. Char start. At this point, this should be pretty easy. I can't call it S, so I'll call it new string is equal to a call to malloc. Right. There we go. And how big should it be? Size of char. Good. Always use that. Even though a char is only ever going to be 1 byte, this is still best practice here. Right. Times length plus 1. Is that math correct? No, what's wrong with it?
The order of operations.
Yeah, order of operations, I should put that in parentheses. It'll result in the same thing in this case. Why? Because a character is always 1 byte. So the math works out to be the same, but for the wrong reasons. So always do correct math. Get rid of your cruft. Right, there we go. All right, copy over the new characters, or starting at index up to whatever. All right, so for int I equals a start index, I is less than start index plus 1 length minus 1 high plus plus. Right. We can do this character by character if we really want to. The new string of I don't have an index here. Is equal to the old string s sub of I. Now again, I only want to copy over Husker here, right? Are those going to have the same indices? We've seen this problem before, where I'm copying from one array to another array, but I'm skipping elements over here, right? Or I'm skipping elements down here. In other words, I've got 2 different indices here, and I want to keep track of them differently. Right? So I'll say int, new str index. Where should I start it? Or do you always start indices? 0, right? And that's where I'm going to copy it over, right? We saw that when we filtered, I think, an array for positive numbers or even numbers or whatever it was, right? No, we're not going to copy this. So we advance that index. Oh, we do copy this. So we advance this index and we advance this index after we've copied them over, all right? What else do I need to do, though? I advance 1 in the for loop here. What about this one down here? New index, plus plus. Okay. Or you could do this with some mathy stuff, right? Here's the offset, so it would be I minus new index or something like that. You could get fancy there, but that's good enough. We're going to replace all this code with something better anyway. Right? Return the new string. Return new str index. Uh-oh. What did I forget? Step 2.5. So you copy over HELLO. What goes at the end here? Null terminating character. So new str of wherever it is at the end. Sorry. There we go. Or we could say length. That would be equivalent because we've broken out of that loop at this point. Is equal to the null terminator. There we go. Okay. Let me get rid of this stuff and just put this into the notes so that you have it. And this formatting. There we go. All right. I didn't want to lose it, but now let's go ahead and see if this actually works. Char star substr is equal to get substring. Now, if I want Husker out of that string, where should I start? 0, 1, 2, 3. How big of a substring do you want? 1, 2, 3, 4, 5, 6. Let's see if that worked. Printf. Substr is equal to %s and the line. Sometimes I like to format this stuff to make sure that I don't have like trailing white space, because when it prints, I'm not going to see that white space. So I like putting these things into quotes, right? And how do I get quotes, double quotes? Well, I can't use them because they're in strings. I have to escape them like this, right? Substr. There we go. And let's see if this works. Oops. What did I do? Char star. Oh, not index. What do I need to return? The new string. There we go. Thank you, compiler. Huske. All right, I was off by 1. Right. Maybe not -1 then. Right. I was wrong. Well, I should get rid of my cruft anyway. So there we go. Right. There we go. That looks right. That should be 6, right? Yep, 6. All right. Let's do another test case here. I can't have the same variable, so I'll get rid of that. Substring, let's go ahead and start it at football there. So this is 3, 4, 5, 6, 7, 8, 9, 10. I think I got it right. Maybe I miscounted. Football is going to be 8 characters. Let's see if that works. Hey, I got it. All right. So test case after test case here, and you'll be writing your own test cases for your. It doesn't have to be too bad, right? Just pick a sentence, right, and go with it. Right. It doesn't have to be too much work there. Then run it through Valgrind, of course. We are going to get 2 errors here because of the memory leaks. That's all right. We can go ahead and free substr and free substr. Oops, not that. Right there. And get rid of those reported memory leaks. Right. And everything's fine. I want to improve this, though. Okay? I don't want to have to do all of this work myself. Right? I'm going to replace this entire for loop with a string library function. Right? All right, let's think about this. In fact, I'm going to replace all that. Right? We want to copy over the string to new string, but of length of the given length, starting at the given start index. Okay? Now let's think about this for a second. In fact, let's go ahead and visualize this. I'm going to go ahead and put this into Python tutor, right? And visualize this execution. Let's go ahead and copy over Husker again. Okay? So where would I start? I would start at that index right there. All right. So let's edit this code and let's think about this as a type of variable, right? So the type of str is what? It's hidden. I didn't write star here. Instead, I initialized it with these square brackets. But the type of string is char star. In other words, a string. Now, I want it to start at index 3. We want to start at index 3. In other words, str sub 3. What is the type of str sub 3? By indexing it, it's no longer a pointer. What is it? Just one, I mean, we've got a character array, right? One thing in that character array is a character, right? It's a char, right? A single character. In other words, we've dereferenced it. Right? So you can dereference something by putting a star in front of it. Another way that you can dereference it is by using this. Now, if I want to copy something, I need a string. strcpy needs a string, or needs a string to copy from, right? That's fine. How do I take this regular old character, a regular old variable, and how do I transform it into a pointer so that it's a string again? Regular variable to a pointer. What operator is that? Ampersand. Right? So let's think about this. Char star starting point, starting string, is equal to ampersand str sub 3. Let's look at that visualization there. Right? There's Go Husker Football. Loaded in there. There's the third one, which is going to be H, or the fourth one, index 3. And here's my pointer to it. Right? So basically what I've done is I've started a substring by getting the memory address not at the beginning of the string, but somewhere inside of it. Right? So I've jumped 4 bytes over, basically. And there are other ways of doing this. Most C professionals would actually probably take the memory address and then just simply add 4 to it, right? Because it's 4 bytes away. Right? That's called pointer arithmetic. It's not something we're going to get into, though. We've covered it before when we were talking about how arrays work and why they start at 0, because pointer arithmetic is an offset from the beginning of a memory address. Right? Well, now that I've got that, I can copy. Right? I can use strcpy into the result starting string. Right? Let me go ahead and give myself another character array here, result. I'll just make it large enough that we don't care that we're filling it up. Right? Now let's watch this. Right? I didn't have to write my own loop in this case. Right? All right. I have a pointer to it. I give that pointer over to strcpy, and it ends up copying from that beginning location now. Now the problem is, it copied all the way till the end here, right? Football, and then a null terminating character there. That's fine. Let's talk about these byte limited versions of these things. Byte limited versions. Where are we? Oh, come on. All right. We'll just do it over here. So, byte limited versions. strcpy and strcat both copy or concatenate the entire string, beginning to end. Beginning to end. There we go. However, we have 2 other options here. strncpy and strncat are byte-limited versions of this, of copy and concat. And catenate. There we go. Looks like there was a question. Oh, okay, not a question, just saying hello. Right? Probably a bot. Anyway, each takes a third argument. N. Right? This is where the N comes in. strncpy, strncat. Right? And copies or concats at most n characters or bytes. If it sees the null terminating character before n bytes, it stops and copies the null terminating character for you. Right? So that's why we say at most, right? If you said n is 1,000, but there were only 5 characters left, it's not going to blindly copy 1,000 characters. It's going to copy those 5 characters, see the null terminating character, and then stop. Right? It saves you from yourself. However, if it does not see the null terminator in the first n bytes, it does not copy or insert it for you. So be careful, right? This is one of those cases where if it doesn't put the null terminating character in there for you, you need to manually put it in. Okay? All right, so let's come over here and modify this program for this one particular case. I don't want to copy over the entire string. I only want to copy a part of it, strncpy. And since I'm copying Huskers here, I'll go ahead and put in 6. Right? So let's go ahead and visualize this before we fix it. There's still a problem here. Right? Okay, so next. I've got my pointer. strncpy is now only going to copy over 1, 2, 3, 4, 5, 6 characters. So next, right? Husker. What is noticeably absent at the end of that string? Null terminating character. So what do we have to do to fix this? We have to? Well, we could append it, but that would assume that if you're going to call one of those functions, you already need a valid null terminated string. Otherwise, it's undefined behavior. So we'll have to set it ourselves. Result sub something is equal to the null terminating character. Now, what should that something be, at least in this case? Husker 7, right? Or index 6. Again, let's visualize that. No, we're not going to pay you. Right? All right. So go Husker, football, right? There's the pointer to it. There it gets copied over. And then finally, in index 6, if you can see it right there, it's pretty light. But in index 6, now it's a properly null terminated character. Right. Let's take this and rewrite our code to reuse the library stuff. Right? All right, so come over here. And let's now copy over S in a new string, but of the given length starting at the given index. All right? So we don't need another variable here, begin index. We don't need that. Instead, all we need to do is take this as our input to this. We can get rid of that one. Now, it's not always going to be 6. It's going to be length, right? And it's not always going to be 6 here. It's also going to be length here. All right? Clear this, recompile it. Oops, did I screw up? It's not begin index. Start index. There we go. And it's not str. What is it? S? Okay. And it's not result. It's new string. I was using a completely different set of variable names. I don't know why. There we go. Same behavior as before. But I didn't write my own loop to do this. I relied on strncpy. Anytime that you can rely on a library function to do something, right, less work for you, less error prone, right? You have fewer points of failure, right? Because this stuff, this stuff is bug free essentially, right? If this were not bug free, then we've been doing something wrong for the last 40 years, right? All right. So I will, however, make sure that you have this in your notes as a demonstration, right? So substrings, see. All right, there we go. It's all pointer arithmetic and pointer manipulation, okay? Let's see, what else did we want? Oh, there was one more thing that I wanted to do before we went on to tokenization. I guess maybe not. Oh no, I know. This will probably this exercise will probably help you, especially for your hack this week. Let's go ahead and create a function. Oops. This function creates a new string, a copy of the given string with all white space removed. Right? So for example, I'm just going to go with Go Husker Football here. If the input is like this, then the output should look something like this with all of those spaces removed. Okay? So we want to remove characters. All right. We can do this in 15 minutes. Then we'll do tokenization on Friday. That's where we're really processing data. It's called CSV data, comma separated value data. It's what you would typically see in like an Excel file or something, right? Tokenized data. Right. All right. So what should I call this first of all? No white space. No white space. That's kind of a noun though, right? Or an adjective phrase, adverbial phrase. I have no idea what it is. But I kind of want a verb because functions do things. Remove white space. Okay, I like that. All right. Const char star s. I don't have to pass in the size because I have strlen available to me. I am making it const because what am I going to do? Create a new string, a new deep copy string. And I'm going to replace, come on, char star. There we go. So I'm going to return a brand new string here. Okay? All right. Error checking, obviously. Do error handling. All right? I'll let you do that on your own. How am I going to achieve this example here, though? All right. Well, first of all, I need to, one, create a new string that is the correct size. In fact, I'll even put that in quotes there. Right? I'm going to combine something that we did before. I told you, well, wait, what if we had a buffer? Right? Do we need to know how big it is? It should be. Well, you actually maybe save this for later, right? How many in this particular example? How many characters am I going to remove? 2, right? Is it always going to be 2? No. So I want to know 1A, how many characters are going to be removed? Right? So let's write that code really quick before we move on to the rest of our whiteboarding. Right? What do I need to do? A for loop. For int I is equal to 0, I is less than strlen of s, I plus plus. If the ith character is white space, then increment a counter. Right? So I need that counter first. Int num spaces. What should I initialize that to? 0. If I did not initialize it, what is in there? Dead beef garbage. Right? There we go. So how do I determine if the ith character is white space? If is space. Good. Right? That's C-type library. Right? And S of I. Right? If it's a white space character, then I will go ahead and say num spaces plus plus. That's incrementing the counter. I've answered my question. Right? We are going to remove that many characters from the original. So now, create a new string of the correct size. Char star result is equal to a call to malloc, size of char. And now what is the new size that you want? Well, it's going to be the old size, strlen of s, but you don't need those num spaces characters. But you do need what? Y plus 1? The null terminating character. There. That's going to ensure that I have exactly the amount of space required for this result right here. Right? In fact, what I would do if you're having trouble, putting all this together when you're actually programming stuff, do incremental debugging. For example, I can say, now this is poor man's debugging, but I could say printf. Actually, no, screw poor man's debugging. Let's actually debug this properly, right? So what I'm going to do is I'm going to call this, what was it called? Remove white space. There we go. Remove white space on my original string str, right? I could set up a bunch of print statements to say, here's the original size, here are the number of spaces, here's my new length, right? But then I would have to erase that code. Right? And then, oh, I screwed up and I need to restore that code because I've got another bug and I may need to make sure that that's correct, right? GCC demo G, and I'm going to run GDB on this. Right? Layout, SRC, and break at, what was it called again? Remove white space. I want to make sure that everything is working before I proceed because there might already be a bug. Right? So let's go ahead and run this. Refresh if I need to. All right. I don't want to walk through this because I don't want to walk through go Husker football ... So I'm going to go ahead and break at line 71 and then continue. All right. There we go. Now let's find out if our new size is correct. Print num spaces. Remember that there were going to be two, right? 2 spaces there. Hey, it worked. Right? Print strlen of s minus num spaces plus 1. 19. Is that correct? Well, go through and add them up, right? How many characters are in this result here? Go Husker football. Right? You can count them if you want, or you can use an online tool, online character counter. Right? Say what? Is it right? There. Go Husker football has 18 characters, but it was 19. What's that plus 1? The null terminating character. Right? Good. Right. All right, so I'm assured that I don't have a bug here yet, right? Or I have some high assurance here. All right. Now in the next 5 minutes, can we copy that stuff over? It's exactly the same process that we did when we filtered out an array, right? All we need to do is set up another for loop here. In fact, I'm going to steal that entire for loop there, right? For each character in the original, if it's a space, I'm not going to count the number of spaces, but if it's not a space, then copy it over. Right. Else, ignore the character. Right? Well, should you have a dead code here like this? Else, ignore the character means do nothing. Right? Should I have a block that does nothing? No, that's dead code. Right? So if it's not a space character, copy it over. Results of question mark is equal to s of I. So what's that question mark? I've got 2 arrays. I'm copying one to the other, but those indices don't always match up. So I need another index. What would you call that index? Could I use I? J. Okay, J. Why? Because J comes after I, right? So J. What else do you need to do? I is moving this way. J, when you copy something over, should also increment. J++. Right? Now, what am I forgetting at the end here? This copy is over. Go Husker football. What do I need to manually copy at the end since I'm not using a library that automatically copies it for me? Results of something is equal to the null terminating character. Right? What is that something? J. Right? J starts out, and J starts out where? 0. It gets incremented. It still exists outside this loop, and so it'll end up that way. Right?
Wait, why'd you have to do the result one again?
This one?
Yeah.
Because I'm not copying over the endline or the null terminating character, right? I'm just copying it over if it's not a space, right? I could, knowing that it has a null terminating character, I could do this instead, and then I wouldn't need this down here. Right? So there's more than one way to skin a cat, as the old people say. Right? Husker, oh, I didn't actually call it, did I? I'm not doing anything with it. So char star new no white space is equal to, and then let's just steal this code right here. No white space is equal to no white space, no white space, no white space. Ah, darn it. We've got a bug. What should we do? Panic? Shut it all down? Delete everything? Delete everything. GDB a dot out. Break at remove white space. Sometimes just walking through the program is enough to determine what happened. SRC. All right, run. Refresh. We know that this worked, so let's go. All right, scroll is way too sensitive there. All right, break at line 75 there. All right, and they'll continue. All right. I know that everything was correct up to that point because I had already checked it before. So let's go ahead and go next, next. All right, so is that first one going to be a white space? Print S. Nope, go Husker football. So we'll copy it over. Okay. Print result. All right. It's got that G. What is the rest of that garbage? Undefined. Undefined, exactly what I said, garbage. All right. So next, but you're not airing out because you're in a debugger here. It's a little bit more forgiving. Next, next. It's not a white space character, O. So we copy it over and print result. Now we've got that O. How do I watch that variable? Watch S, a result. There we go. Anytime that it changes, it will automatically, come on. There we go. Oh, I guess we skipped that. It was a space, right? Go space. And that's why it skipped, right? It should be changing though. All right, fine. Print result. Apparently it doesn't work on strings. Go Hus. All right, fine. Let's go ahead and set a breakpoint at line 83 and continue. Print result. Looks like it works to me. Right? Print, or next, print result. Looks like it works to me. Right. So this is actually one of the bugs that was in your debugging hack last week. I'm at line 89 now. I'm about to return from the function. What's not there? Well, return something, right? I could have saved myself a lot of trouble. How? Wall flag. Reaches the end of a non-void function, but you haven't returned anything, right? Return result. Clean up after yourself with a cruft. GCC. Don't have to run GDB, just run it once and see if it works. Run it once through Valgrind to see that there's no errors. Right? Now hand it in. It's probably going to work, right? Because you've got clean code here, no memory leaks, no errors, and you were able to get it to work on at least one test case here. Okay. All right, that will all be in the notes tonight. Otherwise, we'll look at CSV data and processing CSV data on Friday.